I'm solving another AC circuit problem using the complex number approach. We are given a circuit consisting of a capacitor and a resistor that are connected in parallel, and together they are connected in series with an inductor. We are asked to find the relationship between the resistance, the capacitive reactance, and the inductive reactance such that the total current of the circuit is in phase with the applied voltage. In the complex number approach, we associate a real number with a resistance and complex numbers with the inductive reactance and the capacitive reactance. The last two, the complex numbers, have no real part, while the imaginary part is negative for the capacitor and it is positive for the inductor. Notice that I'm using the notation J squared equals to -1 as opposed to I squared equals to -1 to avoid confusion with the symbol for the electric current. Once we introduce the complex numbers, we can treat the AC circuits the same way we treat DC circuits consisting exclusively of resistors. Specifically, we notice that the capacitor and the resistor are connected in parallel, which allows us to find the equivalent impedance of these two components of the circuit. Notice that we use the same expression that we normally use for resistors connected in parallel. Furthermore, this new equivalent impedance is connected in series with the inductor, and therefore we can find the total impedance of the circuit. Again, notice that we use the expression that is similar to the equivalent resistance of resistors connected in series. We are able now to calculate the current using Ohm's law. The current is going to be the voltage divided by the total impedance. However, because the problem requires the voltage and the current be in phase, the imaginary part of the impedance must be equal to 0. Hence, we found the relationship between the resistance, the capacitive reactance, and the inductive reactance that satisfy this condition. Furthermore, we can find the current to the circuit, which is equal to the voltage multiplied by the ratio between the resistance squared, the sum between the resistance squared and the capacitive reactance squared, and divided by the product between the resistance and the capacitive reactance squared.